Hey guys, so today we are going to talk about the numerical aspect of this chapter. That is, if you get a sum, how do you solve it and what formula you will be using to solve this problems. Okay, so the one we learn about today is called as length formula. Okay, it's in the name. Whenever you have a length, you use this formula. Okay, so if you remember in the first chapter we studied about something called mirror formula. It is pretty much similar to mirror. The only thing that applies for mirror, this applies for lens. So to give us an idea about this, I'll first draw a diagram. Okay, diagram we are familiar with. This is a convex lens. Okay, so I'll just take any random diagram that we know. I'll maybe take this one. Okay, between C and F, what happens to the light? The first ray goes to the focus. This one we are aware of. The next one goes through optic center. You see, right? So basically, the image will be formed beyond C. It's okay, forgive my crooked lines, but please use a scale to draw. Okay. Now, this is a complete diagram. Now we need to do is add numbers to it. So as you know, these are all distances and sizes, right? So what we'll do, we'll look at the different distances that you can find over here. Okay. Firstly, this is the object. So if you notice, the object, it has a certain distance from the lens, right? We call that as u. U is nothing but object distance. Okay. So u is object distance. Similarly, the image is also at a certain distance from the lens. This is called as V. Okay, I hope you are not getting confused with the overlap there. Okay, so this whole distance is V. V is nothing but image distance. Alright. Now, how far is the object? How far is the image from the lens? Done. The next thing that we can look at is what is the focal length. That is quite simple, right? The distance between the lens and the focus. It can be this focus or that focus. It's pretty much the same. Okay, so this is called as small f. Alright, so f is nothing but focal length. Alright, now finally what we have, size of the image, size of the object, how big is it or how tall is it, right? So this is the size of the object, this is the size of the image, right? So instead of size we say height for this tall, right? H O is height of object and HI height of image, as simple as that. So This is what I will write here: height of object h rho and hi, which is height of image. Simple. Right. So if we know these values or some of these values, we can find the unknown values using a certain formula. Length formula goes like this: 1 by f, okay, that is the inverse of focal length, equals to 1 by v minus 1 by u. Okay, this is your length formula. 1 by f equals to 1 by v minus 1 by u. If you remember the mirror formula, the difference in this minus is a plus. Okay, 1 by v plus 1 by u is the mirror formula, but this one specifically is for lenses, called lens formula. Okay. This only uses three values, that is f, u and v. Now there is another formula that we can use that uses the object size, right? So there's another term that we call magnification. Okay, by magnification we mean how much is the size changing. Is the object smaller than the image? Is the object bigger than the image? Right? So that size factor can be calculated using magnification formula. Okay. So magnification is called small m for magnification, right? So one way to find magnification is v divided by u. Okay, that is nothing but image distance divided by object distance. Okay, now if you recollect, minus v by u was magnification for mirrors and v by u is magnification for a lens. The only difference is that minus is not there over here. Okay, you also recollect that another way to find magnification is height of image by height of object, right? This is same as how we had the one in the mirror chart. So these are two different ways that we can find magnification, which also means that these two can be equal to each other. So magnification is v by u, which is also height of image by height of object. You can use any combination depending on what information is given to you in the sum. Okay, meaning I can use these two or these two or this and this. It's up to me, right? So these are two formulae that we will be using when it comes to doing any sums. Along with this, there is something called sign convention also, which again, if you've done the first chapter, you will know. Okay, the sign convention is again pretty much similar. We'll take a run through it. We'll talk about the sign convention tomorrow and also look at how to solve problems. But it will be ideal if you can go back and take a look at the video of sign convention before the next class. Okay, so after this video, try to look at the sign convention. Okay, alright, that will make your work easy for the next class. And yeah, that's it for today. I'll see you in the next one.